In section 2.3, numbers 7 through 12 are all very similar. I'm going to do number 7 as an example, and you can apply that same techniques to all of these. So we're going to find the height of the indicated floor of a skyscraper, given the angle of elevation, theta, at a point 40 meters from the building. So you can think of that as a little guy, or you, standing here, 40 meters away from this building. So you're 40 meters away, and you look up. And when I look up at the 4th floor, that's number 7, the 4th floor, so 1, 2, 3, 4, I'm looking up at an angle of 15.3763 degrees. Okay, and what I want to know is the height of that building at the 4th floor. So that's my unknown variable. So I'm going to pop this triangle out just to get a better view of it. I have the angle theta. I have the adjacent leg is 40 meters. That's the distance I'm standing away from the building. And what I want to know is the height at the 4th floor. So there's my x. Excuse me. So if I look at SOHCAHTOA, the 3 things I need in my equation are going to be the angle, so that can be any trig function, an adjacent leg, and an opposite leg, so the A and the O. What I don't have is hypotenuse. So since I don't have the hypotenuse, I don't have it, I don't need it, I don't want it in my equation, then I'm not going to use SO or CA, which leaves me with TOA. That is tangent. So I get tangent of theta equals opposite over adjacent, which in this case is the thing we need, the height. I'm going to let x equal height of the building at that floor. And the adjacent leg is 40 meters. Okay, so solving for x, so I have tan theta equals x over 40 meters. So if I'm given theta, so what I want to solve for is x. So to solve for x, I'm going to multiply both sides by 40 meters to get x by itself. And then it's just a matter of plugging in that theta. So in this case, on number 7, I'm going to switch to blue because for number 7 I did a little blue there. So for number 7 I get 40 meters times tangent of 15.3763 degrees. So this one is a calculator. It doesn't actually say to... Okay, it doesn't say to round it. It's to find the height given the angle. So this is the exact answer. This is what I would expect. Actually, the meter would be at the end. That's the units, right? So that is the exact value. This is what you would give if you don't have a calculator. The directions aren't clear if we're going to round or give the exact value in the answer, so maybe there's some directions above that I didn't see. So we'll just do both. So that's the exact value. And if the question says to round, let's say, for example, let's say it says round to the nearest 100th place. Excuse me. So then I would do that into a calculator. So I have 40 times tangent of 15.3763. And this calculator, I enter it like that. Some calculators, you have to do the 15.3763 first and then hit tan. So some calculators are a little different. That one gives me this answer, and I get that to run to the nearest 100th place, I get that the height for number 7 let's see, x equals 11 meters approximately. So at the 4th floor, the height is 11 meters. So that is the answer for number 7. And as you can, hang on, let me make that pretty for a set first before I, so this is my final answer for number 7. Okay, when I go on to 8, 9, 10, 11, or 12, I can apply that same work that I just did. Let's do it in orange. So for example, number 8, it's going to be the same work up till this point when I solve for x. And the only thing that I'm going to change is the theta. So for number 8, I get 40 meters times tangent of that angle, 57.1715 degrees. And that's going to equal the height of the 21st floor. So that same process is going to be applied to all of these problems.